Greetings, this is Dr. Derek Ong with the continuation of the SPSS analysis for quantitative research. In this video, I'm going to talk to you a little bit about reliability and factor analysis. Now, in my previous video, I have shown you how to do data analysis using multiple linear regression for single items. Now, if we have a questionnaire which allows us to do multi-item scaling, as in the case from this paper that I've written, investigation of mall atmosphere in the experiential shopping during holiday season, what we had done is we tried to look at the impact of perceived crowding, consumer density, interior setting, employee engagement, and music on consumer behavior during Christmas. And that was the main research objective that we wanted to use. The framework that we had used, of course, was looking at the H1, which is perceived crowding, consumer density, interior setting, employee engagement, and music. These four are basically multi-item scales, whereas the perceived crowding is just a single item scale. So if we look at the questionnaire, so this is where we want to look into interior settings, music. As I mentioned, consumer density is a single item, perceived crowding, and employee engagement. So what we do with multi-item scales is that first we pilot the questionnaire and we do reliability testing using combat alpha. Usually a pilot test of 30 would be enough. Other considerations are on a case-to-case basis. And then after we have done the reliability testing, we shift around the items to ensure that they are reliable in getting the results that we want. And then we do the data collection, the full data collection from the sample sizes, the minimum sample sizes that we need to achieve the minimum power and the effect size. So after the data collection, we do the factor analysis to ensure that the factors are good. And then after factor analysis, we create the summated scales using transform. And once the transform variables are done, then we can use the multiple linear regression to do our hypothesis testing. So let's look at how we do reliability testing using the mall atmosphere. So I've got my data sets here. So I've got IS, which is the interior setting, M, which is the music, CD, which is the perceived crowding, PC, which is the here perceived crowding, PC. Consumer density is 1. Sorry, consumer density is 1. Perceived crowding is multi-item scales. Yeah, so perceived crowding is multi-item scale, consumer density is 1 item, employee engagement, and of course our consumer behavior here is the dependent variable. Just to make note that when we do reliability, we have to do each and every single one of the combat alpha as variable by variable. So let's just do for the interior setting first. We go to analyze, we go to scale, reliability analysis, choose only the items belonging to interior settings, push in, press statistics. The important one that we want is scale if item deleted, continue, OK. looking at the analysis, we want to look at item total analysis, which says here there's 5 items and the crowbar alpha is 0.856. And if we look at this column here, the crowbar alpha if items deleted, if any of these items is above a 0.856, what we do is we delete that item, as in we do the reliability again without that item inside, and then we check again to see whether or not there is any items or crowbar alpha which is higher than 0.856. So in this case, all the items are good, and hence we can use all the items for variance maximization for the factor of IS. Moving on, we do music, which I suspect there is a problem. So we take out the IS and we put in music. Yes, noticing that music, our crowbar alpha here is 0.626, and the highest crowbar alpha for us to delete is of course M9, so we take away M9. Now there's two school of thoughts here whereby we take away one at a time, or we take away all the crowbar alpha which is higher than the all the items that's higher than the crowbar alpha. However, if we do the second method whereby we take out all the items that's higher than the crowbar alpha, we won't be able to see the incremental changes of the crowbar alpha in the items. So let's just do one at a time. Analyze scale, remove M9, 0.643. Again, we have something that's high, M4. We go again, analyze, scale, take out M4. And we notice that the scales, the crowbar alpha is getting higher, but still, it is still unstable, so we have to take out M7, which is the highest here. And again, we need to take out M9, M8. So we basically have to do this until the variable is stable. 0.792. Now, in this case, because removing crowbar alphas which are higher may be quite detrimental to the reliability of the statistics. When we look at things like this, we tend to have to go on a judgment call here, because the crowbar alpha needs to make sure that it reaches a minimum of 0.6. But in this case, my M6 is 0.793, which is not too far off from the main crowbar alpha. So what I'm going to do is I'm going to just leave this here, and I am going to just report this as M1234, M12356. Yeah, and I do the same for the other variables like employee engagement and also consumer behavior. And finally, I will get this reporting. So I do this for all the variables. Yeah. Notice that my M6 is not here. And I'll explain to you why my M6 is not there. But for now, I'm going to be including in my crowbar alpha. But just remember to put in the variables, the number of items that you retain, the items that you retain, and of course the cron by alpha from the reliability analysis. So this is the variables that you keep, and in the next video I'm going to show you how to do factor analysis. But for now, use these variables, these items. So that means you go back to your questionnaire and you take out all the items that is not represented here, which means they're not reliable, and you do your data collection. Okay, that's all now for reliability analysis. Thank you.